So, welcome students to my next lecture. So, our subject is finite element analysis, and in this lecture, we are going to solve this problem, which you can see on the screen. So, what is given in this problem here? You can see in the problem we need to determine the elongation. So here spring system is given. So in this spring system we have different stiffness values. So here for first spring, which is in between node 1 and node 2, its value is given k1, which is 500 newton per meter, and the second stiffness value for spring 2 is given, which is 100 newton per mm per meter. And if we will talk about nodes, so this is node 1, this is node 2, and this is node 3. uh, Here node 1 is fixed, so the node 1 is entirely fixed, and for node 3 there is a 5 newton force is applied, which is heading towards right along x direction, right? So for this problem, first we need to define, let's say, the value, let's say the element stiffness matrix for this element k1. So I'm going to define k1 matrix, which is element stiffness matrix. So for k1, so I'm writing here k1 can be defined as, so k1 is equal to, so the matrix, now here the standard matrix is 1 minus 1 minus 1 and 1. So here the value of k is given for the first spring, value of k is 500. So this matrix I can write as 500. So 500 minus 500 minus 500 and 500. So this is the first k1 matrix. So definitely this matrix is in between node 1 and node 2. So here I am writing 1 2 and 1 2. So as this node, this particular stiffness is in between node 1 and node 2. So likewise I am defining k2 matrix. So we can define k2 matrix. Say k2 matrix is defined as, so first is 100 minus 100 minus 100 and 100. So these are the stiffness values. Definitely this particular element is in between node 2 and node 3. So I am writing 2 here, 3, 2, 3. So here we can write 2 3 2 3, right? After this I need to establish a global stiffness matrix. As you can see, this is called as local stiffness matrix. Now, to have a global stiffness matrix, so I'm defining K matrix as a global stiffness matrix. So it is definitely combination of K1 and K2. I need to place all these values to its position. What I mean to say is this particular element is at node 1, which is at row 1 and column 1. So I need to keep this at, while combining the matrix, I need to keep this to its position. So I have written 1 2 3 column wise as well as 1 2 3 row wise. So here I am writing first element is 500, which is at row 1 and column 1. So second element I am defining, which is minus 500. It is at row 1 and column 2. So minus 500. Sorry. So what I will do, I will erase this, uh, erase this line, and I will try once again. So here I am writing minus 500. Okay, so minus 500, sorry, my bad. uh, Minus 500, and here, so this is minus 500, which is placed at row 2 and column 1. So here I have to write minus 500, and here I have to write 500. So likewise I have arranged first matrix in the global form. Now this is the second matrix which I have to arrange in global form. So here, if I will see, this element is at 2 position, row 2 and column 2 position. So here row 2 and column 2 position is here. So I need to arrange this particular 100 here. So I'm writing 100. Now this position is row 2 and column 3. So minus 100, and likewise I will write all the elements. So this is minus 100 and this is 100, right? Then wherever you will not find any element, I need to put there 0. So here you will not find any element, and here also I have to put 0. So this is your global stiffness matrix. Now here I have found global stiffness matrix. After this I am going to define the matrix, like K matrix, K matrix into Q matrix. So into Q matrix will give you F matrix, right? So here K is stiffness value, Q is displacement or deflection at the particular node. So I will erase first. Sorry, erase this. Okay. So here I have written K matrix into Q matrix will give you F matrix. Now, if you will see this problem, the force at this node is like, here the node is fixed, so there will be no displacement. So I have to write here reaction. So there will be reaction at this particular position at this node. Now this node is free to move, there will be no force given. So I have to consider there will be no force, and here 5 kilonewton is there, right? Now let's assume that q1, q2 and q3 are the displacement at respective nodes. Now here I am writing the value first. uh, First matrix is K matrix, so I am going to define K matrix here. K matrix, so here value is 500, minus 500, then 0, then minus 500, 600, and minus 100. Last column is 0, 100, and sorry, this is minus 100, and after this is 100. Now this is K matrix multiplied by Q matrix. So as I said, Q1, Q2 and Q3 are the displacement at different nodes, is equal to F matrix. So I need to define F matrix. So how I can define F matrix? So first force, if at node 1 I am getting reaction, at node 2 there will be no force, at node 3 5 Newton force is given. So I am writing 5 Newton over here. So 5, right? Now as node 1 is fixed, I am using elimination approach. So here in elimination approach, what we will do, the node which is fixed at at that node, we are going to remove that row and column. So in this case, node 1 is fixed, so I'm going to remove row 1 and column 1, so that uh, it is showing the effect of node 1 is fixed. So this is called as elimination approach. Now the rest, the thing which is remain here is, so I'm having 600 q2 minus 100 q3 will be equal to 0. Then minus 100, this is equation number 1. Now minus 100 q2 plus 100, sorry, so the equation is here, second equation. So minus 100 q2 plus 100 q3 will be equal to 5. So this is equation number 2. Now what we are having two equations and two unknowns. So we can easily find out the value of u2 by solving this equation. So u2 here in this case is 0.01. So once again I am writing u2 is 0.01 meter, and likewise, so q3 value is 0.06 meter. Once again I am writing, this is I'm just erasing this. uh, so here the value of q2 is 0.01 meter, and value of q3 is 0.06 meter. So this is how we have find the nodal displacement at particular nodes. Now if you just want to find the reaction at support, then what we need to do is we need to consider the this particular row which is we have eliminated. So here we have 500 um, q1 minus 500 q2, which will be equal to r. After this, if you will put instead of q2 0.01 and instead of q3 0.06, then we will have a reaction at the end which will be minus 5, right? So try to put here instead of q1 0.01 and instead of q2 0.06. So in this equation you will have the final value. Reaction at node 1 is minus 5 Newton. So, okay, here we have found the displacement and reaction at support by using matrix method, or this is called as elimination approach. Now we are in next video we are going to see how we can use ANSYS APDL to find all these values. Thank you.